Hello everyone, Mr. O here, doing part two of Shikaku. So we're going to try a couple more challenging puzzles and see if I can give you some tips and tricks, something to get you moving on your way. Follow along with me and we'll do a couple of these together. Let's try one from the level 3 worksheet. Shikaku level 3. So let's try this one here. This is a big puzzle. Okay, got a couple challenges. But I notice again, I always go right to the corners. And the corners are good indicators of how it's going to work because the 3 is the only thing that can reach into that corner. So that would be a good, helpful hint there that goes to the corner. This 12 is in a corner. So could it go across? These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That could fit perfectly right there. Or maybe it could be a 2 by 6. So that's a good question to ask and to wonder about. 1, 2, 3, 4. This corner could be the 6. Could be a 3 by 2, or it could be a 4. We have to come back to that. It certainly can't be the 2. This 2 could go up here, the 3 could go up there. So there's a couple things that are unknown at this point. This corner. Think about who can reach this. Well, there's no numbers up here. 3 can't, the 6 can't, there's a 3 there, there's any big numbers. 7 is going to be either horizontal or vertical. 21 is the only thing that can reach there. So that's what I'm talking about when you're looking at the corners. Only thing that could possibly reach here is the 21. And since it can't be a 21 by 1, it's going to have to be a 7 and 3. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So that's going to be a very good, helpful number to find because now we know this 12, right? Because the only thing that gets in there is this 12. So this 12 is going to have to be horizontal this whole way, right? What could possibly reach this corner? Well, the 4 could, 1, 2, 3, 4. But then we need to think about this and maybe this 8 because the 2 can't reach there. Otherwise, the 4 is a vertical. 1, 2, 3, 4. This 8 cannot get down here. The only thing that can reach down here is this 4. This 8, 1, 2, 3, 4, 4 by 2 does not get to this corner. So that's the only thing that can reach there is that 4. So that's helpful. And then the only thing to reach here is the 8. Because this 2 can't, the 24 get to here, but not here. So this 8 is going to have to be a 2 by 4. Reminds me of a song, 2 by 4. All right, 1, 2, 3, 4, 5, 6, 7. 7 can fit there. Could it go vertical? 1, 2, 3, 4. Nope, it cannot. So 7 is going to have to go here. Sometimes these things just kind of fall into place, which is nice. All right, this 4 could be a 2 by 2. It could be a 4 by 1. I guess we'll have to come back to that one. This 2, what could reach here? 1, 2, 3, 4, 5, 6. The 6 could come down. So we'll have to worry about that in a second. But let's look at the 24. 1, 2, 3, 4, 5, 6. Could we do a 6 by 4? Sure could. Could it be a 12 by 2? 1, 2, 3, 4, 5, 6, 7, 8, 9. It cannot be a 12 by 2. 8 by 3. Potentially. We have to look at this 21 and see how this 21 is going to fit as well. There's some real question marks here, how this 21 could fit in here. We've got big numbers. Generally, big numbers, I think, are helpful to go to first because you see that there's only certain locations they could be. This 32 is, you got a couple choices. 8 by 4, probably the most popular. I mean, 16 by 2, right? But let's see. So there's a bunch of stuff up here that can't be reached. 1, 2, 3, 4, 5, 6. 6 can't get up to this upper row. This 3 could potentially stretch 1, 2, 3 to here. And this 2 could stretch to here. But this, up in here, this has to be part of the 32. Right? So I'm looking at 1, 2, 3, 4, 5, 6, 7, 8. We don't know exactly where this 8 is going to start. But it's going to be 8 by 4. 1, 2, 3, 4. And so we know a bunch of this is going to be our 32. And I kind of just drew a rough outline since we don't know if the 8 starts here. 1, 2, 3, 4, 5, 6, 7, 8. And then this is 3 and this is 2. That could potentially be it. But we got an idea of where this 32 is going to be. So that helps. All right, this 8. Think about this for a second. 8, 1, 2, 1, 2, 3, 4 could go up to like this, right? Which would mean our 6 has to find somewhere to go, and so on and so forth. If this 4 were to go up, 1, 2, 3, 4, this 3 could go 1, 2, 3, or 1, 2, 3, but we would have a couple spots in here that need to be filled. The 4 can't get there. The 6 can't get up here. 1, 2, 3 by 2. what could possibly reach here? 4 by 2 from the 8. It could reach. So we got choices are the 4 or the 8 could reach here. So I just look at certain squares that are, sort of unknown or only reachable by certain numbers, right? Those are helpful pieces of information. This is 21, which is 3 by 7 in most accounts, right? 21 by 1 is not going to fit on this board. So 3 by 7, and you'll notice that the 6 and this 32 kind of make a nice little 3 window. So 1, 2, 3, 4, 5, 6, 7 fits perfectly between all these numbers. See, the 6 is a boundary, the 2 is a boundary, and then this 32 is a boundary. So this is 7 by 3. Most often when people make mistakes on these, they're just miscounting. So you count off and you think this is 7 and you miscount and you're like, oh, I thought that was 7, but I actually put 8 or 6. 1, 2, 3, 4, 5, 6, 7. 7 by 3 is in. All right, so what can reach here? Only this 3 can reach that square. So we know that to be true. And now we're starting to figure out how this square, 1, 2, 3, 4, 5, 6, that could be the 6 or it could be the 24. 1, 2, 3, 1, 2, 3, 4, 5, 6. It could be a 6 by 4. Could it be anything else, this 24? It can't be 8 by 3 anymore. It can't be a 12 by 2. I think we got a pretty nice fit with a 6 by 4 right there. But then how's the 6 going to go? Well, maybe it goes 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 by 4 this way. 1, 2, 3, 4. Yep. Because this 6, if I go down to here, the 6 is going to have no space. But if I make my 6 a 3 by 2 down here, then this 24 could be 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. And we have our 24. This 2 has to go vertical, this 2 to the right. And then this is 6 by 1, which we already discussed. 16 has to get in here, so clearly it's going to be a 8 by 2. And by the way, if you're working on these and you need to have a calculator next to you, absolutely, you can figure out all these different possibilities. 2, 4, 6, 8, 10, 12, 14, 16 stretches all the way to here. 8 by 2, 1, 2, 3, 4, 5, 6, 7, 8. And then things start to fall together at this point because now we have limited options. This 3 and 4, 1, 2, 3, 4, 1, 2, 3. That means this 3 goes vertical, doesn't it? 6, 1, 2, 3, 4, 5, 6, because the 6 by, it could work. 2, 4, 6 could work. But I'm thinking more along the lines of 1, 2, 3, 4, that this 8 is going to go like this. Why do I think that? Well, let's see. See if we figure this out. What can reach here? What can reach here? 4 can reach there. 1, 2, 3, 4. Then the 6 would have to get here. 1, 2, 3, 4, 5, 6. And would that leave enough room for our 32? 1, 2, 3, 4, 5. It would not. So 6 cannot go like this. And so if it were to go 3 by 2, 4 can go this way. Well, then what's going to go here? So there's a lot of questions. If I start messing with this 4, this 8 going this way, 4 could go this way, but there's a bunch. Then we have to look at what goes here because the 6 would then have to come out to the corner. So 6 could not reach here if the 6 was in the corner. And then our 32, we're lost, right? So that's not going to work. So this 4 does not come out this way. So this 6 does not go like this in the corner. Okay, that means our 4 has to. It means our 8 is going to be 2, 4, 6, 8. And then this 6 runs along the bottom. 1, 2, 3, 4, 5, 6. 2 here and 4 here. Now, all right, if I want to start, let's see, this 6 looks like there's many options. But we only have one option for the 2. 1, 2. And so when I start looking at 32, could I get down to here? Absolutely not. The reason I can't is because the 6 is here. And we have to go to the top, so there's a lot of different reasons this 6 has to fill up this corner. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8. This is our 32. 8 by 4. What can come down here? Well, the 6 cannot because it just can't run horizontal. It has to run as a rectangle with a width of 2 and size of 3. So 2 by 3. This is a 2 here. This 3 cannot go vertical. It's got to go horizontal. 2 goes up, 3 goes over. And ladies and gentlemen, we have solved our puzzle. I'll show you one more online. My goal is to keep this video a little shorter. So I'm just get you started on this one, and then we will. I'll let you finish. I look at the corners and I notice that the only thing to get in this corner is a 6. 1, 2, 3, 4, 5, 6 will fit perfectly right there. This corner can't be reached by the 2. There's nothing can be done here, so this is a 7. By the way, this is a 15 by 15 size. So 7 goes here. 1, 2, 3, 4, 5, 6, 7. And then you look at things like this. This is another corner here. So this 2 could go there. Could the 4? Could this anything else? So we know this 2's got to go like that. So things like that. Looking at corners, right? I look at, well, there's nothing else can reach there besides this 2. Does you see anything else? This is a 15 by 15 puzzle. So this is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Does not reach to this corner, so we got that. And so on and so forth. Now this 4 can only go vertical. The only thing that can reach in there is the 2. And they sort of fall together like that. And choose the different sizes. Challenge yourself. Have some fun with it, ladies and gentlemen. And I hope you are all doing very